Please give me a quick confirmation. All of you can hear me loud and clear and you can see my shared screen. Give me a thumbs up. Yep. Thank you for confirming in the chat. So I can see we have got only 3 participants joined in till now. We'll wait for a couple of more minutes to give some buffer time. Let's see if few more participants join in, and then we'll start our training program with introduction. So let's wait for a few more minutes and let's see if we have few more participants joining in. Okay, I think it's right time to start without any further delays. Once again, on behalf of K21 team, I would like to welcome all the participants, those who have joined. Uh, Warm welcome to Terraform job-oriented program organized by K21 team. Give me a quick confirmation. All of you can hear me and see my screen. Hi, Sean. Good morning for you. Hi, Salim. Hello, everyone. Those who are, I can see some participants still joining in. So we will not do any delay. Let's get started. So this training program is dedicated to HashiCorp infrastructure tool, that is Terraform. So before we start discussing about the agenda and what are we going to learn, let's have a quick introduction so that we get to know each other. So this is Akhil, and I will be your trainer for this entire training program, which will be completely on Terraform infrastructure tool. Talking about myself, about my technical acquaintances and expertise, I have around 10 years of consultation and corporate training experience. And about my acquaintances, especially I take care of DevOps and Linux domain. So towards DevOps, I am a Terraform certified engineer on V2 and V3, as well as certified Kubernetes administrator and certified Kubernetes application developer from Linux Foundation. I also have certification with Ansible as a Red Hat certified engineer working on Ansible. Towards Linux, I am Red Hat certified instructor for Red Hat certified courses, especially RHCSA, RHCE, RHCA, and other courses. For Microsoft, since I interact with Microsoft Azure cloud provider to create and manage my infrastructure, so I am a Microsoft certified trainer as well as technology associate as an administrator level. That's all about me, and I will be sharing my experience of working on Terraform for around more than 7 years. That's the relevant experience that I have with the Terraform. The main motive which I have in my mind as an intention of this training is I want all of you to get skilled how to use Terraform tool, as well as also if you have any plan in corner of your mind to go for certification, can help you in achieving that. So before we start talking about the agenda, I hope all of you must have received the welcome mail and the details to access your dashboard, K21 dashboard, where you can see your courses, your recordings, and all other materials. In case if you are not able to access, or if you have not received the mail, if you have not joined the WhatsApp group, please raise a ticket on support@k21academy.com so that our team can quickly resolve your queries, because it's better to be uh, resolved in the beginning in case if you have any problem with the LMS or with other program details. Now, before I start talking about the course agenda, I would like to know about the audience here. So we have got around six participants, including all the participants, those who have joined, and total 8, including me and the Deepak. So I can see your names as you have joined. So I will really appreciate if you can put in the chat your country from where you have joined, your work experience, if you are comfortable to share your current job profile, what currently you are working, and what are your expectations from this training. Are you looking for getting, skill set to use in production, or you are looking for certification, or you have a requirement, you are looking for a, job change, some better opportunities in Terraform. If you want, you can go ahead and share that with me. That will help me to know you more better. And if you have any experience working with Terraform in case, then you can also let me know that. So these few things in the chat will really appreciate. Thank you, Sean. I remember recently my team gave update that you have passed your Terraform certification exam, if I'm correct. Perfect. Congratulations on that. A really big congratulations. I hope the certification program that you have completed will help you in your future endeavors. So really glad to hear that. So a big motivation for all the participants, those who have joined here. George is our ex-student and he has joined here to get his concepts more clear. Especially, I believe he is here because last session we did on Microsoft Azure, and here this session we are going to do it on Amazon Web Services. So this will make his concepts more clear. So everyone, I really appreciate Barry, Joffy, Oeti, all the participants. Go ahead, put in the chat your country from where you have joined, what is your job role, your experience, and what are your expectations from this course. I really appreciate if you can share this information so that I can get to know each one of you, and then we can go ahead and start the agenda. If you want, you can even unmute yourself and can directly give your introduction. That will also be completely okay. The way you want is completely fine.
Yeah, I'm Jofi here. So I'll just try to introduce myself.
Yes. Hi, Joffy.
Yeah, yeah. Hi, Agil. Yeah, I'm Jofi, and I'm currently I'm just put up in Texas, Dallas, and I have experience, more experience that I was into administration side on the SAP side with some database experience, and then into some cloud with AWS. And then prior to this, also I have just did some course that's for the that's for Docker and Kubernetes. So yeah, so I just want to be in the cloud side more focused on the cloud that is on the AWS or with the Azure. Yeah, for working more on the administrations with the Terraform or the Ansible, and then automating the process. Yeah, I'm
Perfect,
currently
Joffy.
not. Yeah,
So thank you so much for sharing that information. Really appreciate. So you are looking into getting your hands-on on working with the administration tasks of deploying infrastructure using Terraform on AWS or other such cloud provider.
right.
So that is what the entire concept that we are going to gain from this training. So yep, perfect. Thank you so much for sharing that. We have another quick introduction shared in the chat from Oiti as from UK, MSc student, new in technology and looking for better job prospects, working as a cyber specialist, DevSecOps, and also understanding of Terraform to advise and guide developers building application of deploying workload in the cloud space. Perfect. Thank you so much for sharing that, Oiti. And then we have another introduction from another participant, an MSc student, new in technology and looking for better job prospects. Good, thank you for that. So we can see we have different type of experience, cyber specialist, then Joffrey brings experience of SAP. What about Barry and Salim? If you're comfortable to share your experience, your currently where you have joined this meeting and what are your expectations from this training? So Sean has already shared looking for managing existing Terraform resources. Thank you, Sean, for sharing that. Anything else you would like to share, Sean? Please go ahead. Okay, so we have got from Barry as well. Sorry, I missed that. My mistake. So Barry is also joining from USA, trying to break into technology, no previous experience. Okay, thank you for that. Okay, perfect. So thank you, everyone. I really appreciate putting your introduction, sharing your introduction and about yourself with me. So this training is the right place that you all have joined to get your hands-on in technology, on infrastructure automation, creating, infrastructure with the approach of automation, like using infrastructure as a core tool. So let's go ahead and see what is the agenda for this entire training, and especially for this particular module. So in this entire, course, we are going to talk about what is infrastructure as a code approach, what advantages infrastructure as a code brings you on the table when you are using it as compared to a traditional approach of doing it from the console or from the graphical menu. Then what are the different categories of infrastructure as a code tools in the market, and how and where does Terraform fits into that? We'll talk about that. And then once we are introduced to Terraform, we start talking about the Terraform and its benefits. So what is Terraform? Who made Terraform? What are the different offerings of Terraform? How Terraform is different from other infrastructure as a code tool? What benefits Terraform brings to you when you start using it over other infrastructure as a code tools? How it brings you the cloud agnostic feature where multi-cloud benefits are available for the user using Terraform. The architecture, what all the, the workflow, how Terraform works. And then it will be followed by diving into the concepts of writing the configurational files for Terraform. So as I can see that you might or might not have an experience of programming languages like C, C++, Java, or so on. And we don't need that for this training. That's the best part. So if you have, that's an advantage. If you don't, it's not a problem, because we are going to write our configuration files into a very human readable format. And that is why Terraform is very easy to learn. And we have a very faster learning curve. So once we have talked about the workflow, the architecture, we start diving deep into the concepts of Terraform programming, HashiCorp configurations, basically, how to use variables in Terraform, how to use data types in Terraform, how to use functions in Terraform, how to use iterators in Terraform, how to apply conditional statements in Terraform, how to create your own modules in Terraform. We will also talk about generating a graphical visual representation of your configuration so that you can explain to someone who is non-technical. We will talk about how to manage an existing infrastructure using Terraform. We will also move towards the end, and then we will talk about the team collaboration, how you can configure your infrastructure to be, managed in a team. And then you will also explore the features of Terraform Enterprise version, where we get many more features as compared to the other offerings. This is the entire course agenda that we are going to follow. What you are seeing on this current slide is only for this particular module. So we have total 8 modules, followed by the 9th module, that is Terraform job preparation and exam preparation session. So total 8 plus 1, 9 modules. From the training perspective, the content perspective, total 8 modules. And after that, the revision, the exam preparation, and helping you to get your, idea how you can crack the exam. That will be an extra session at the end. So in this entire, we have got 8 modules. This is the first module that you are seeing right now on the shared screen. And the current slide that you are seeing displays the agenda for this current module, where we will talk about all the introduction, followed by the introduction to Terraform, the architecture, and the workflow. Okay. So let's get started. One very important thing I would like to mention here is this entire training program organized by K21 team is mapped with the exam objectives of HashiCorp so that all the learners don't have to again spend extra hours of training program to get themselves certified. After completing this same training, you all will be eligible and will be skillful enough to go for the certification exam. So keeping that in mind, every module is mapped with the exam objective of HashiCorp. So what you are seeing currently, this is the exam objective of the official Terraform engineer, the program that you appear for after completing this training exam if you want to go for. This is mapped with the objective 1 and 2, where we talk about what is infrastructure as a code, the advantages of infrastructure as a code, and the different benefits that Terraform provides, and the benefits of using Terraform over other infrastructure as a code tools. So let's get started with the first topic for the day. Before I start this, I will be taking one break in between. Let me inform you about the breaks. So we will have one official break of 15 to 20 minutes. We will take it around 2 hours past the time we started. So whatever time we started for you, 2 hours past that, we will take our official break of 15 to 20 minutes, and that will be the only break. But in between, whenever needed, if we feel it is getting exhausted, of course, we will take a quick 5 minutes breather so that we can go have a walk, get a glass of tea or water or coffee, and then get yourself back on the desk again. Having said that, let's talk about the first topic for today, that is infrastructure as a code. So we are going to talk about Terraform first. Okay. And Terraform is infrastructure as a code tool. So we need to understand that what is infrastructure as a code? What does this concept mean in the world of infrastructure provisioning? So in very simple words, if I explain this, what we have been doing is we have been using manual processes like going to console or dashboard or other graphical menus whenever we want to create our infrastructure. So let's say if I ask you to create a EC2 instance on Amazon Web Services, so you will go to the AWS console, search for EC2, then click on instances, create instance, select your AMI ID, your instance type, then if needed, key pairs, provide tags, and then create a resource. So this manual process is what we have been using since last many years. And this is just an example of one provider. This has been being used in many other ways, not only just in Terraform, in provisioning, but also in other approach as well, even in management also. But with respect to time, now we are changing the technology and we have moved to automation, in which one of the most and majorly approach that we have changed is instead of manual processes and settings, we have moved to defining our infrastructure as a code. So just imagine it's like one normal text file where you are defining the entire infrastructure definition that you need. For example, IC2 instance with certain name, then this particular image ID, and then you run that, you execute that code, and your infrastructure is created. So instead of manually setting up the configurations and doing everything, we have moved to the approach of defining everything only once initially in a one single file, and then as per our tool, the file is used to create our infrastructure. So that is what infrastructure as a code means. You will get to know very soon from the upcoming slide that what are the advantages of being used this approach. over the manual approach and how it is different. But before that, a quick history about Terraform. Terraform is made by HashiCorp. HashiCorp is the name of the organization who has made this. And till date, they are the one who are managing the release updates and patches, as well as certification programs globally, giving supports, providing enterprise offerings. Everything is taken care by HashiCorp. The latest release when this slide deck was updated was 1.6, but now we have 1.8.x. So Terraform is right now 1.8.x series, and the entire Terraform is written into Go language in the backend. So all the libraries are written in Go language. So developers at HashiCorp, whenever they are releasing, updating, or doing a patch, they do everything on the Go language. But as an end user, we just use Terraform tool. Provider support. Now, what does this provider support means? Think of it as a platform where you can create your infrastructure using Terraform. So I can create more than 2,500 was the data when this slide was created and updated. But till date, today, it has increased to more than 4,000. So I can create my infrastructure on more than 4,000 different platforms by using one single Terraform tool. That's the beauty, or I should say TRP of using Terraform, that it helps you to create infrastructure on different providers, which can be really needful when you are managing a hybrid cloud or hybrid platform to manage infrastructure. So that's a quick introduction to Terraform. On the right hand side, you can see these are some of the providers. Let's not discuss about that right now. We will come back to that later. Right now, getting to know about the organization who made Terraform and what is the language in which the libraries of Terraform is written is good enough for us to start. Gaining popularity, if you see this, the Forbes list, the HashiCorp is almost in the top 5 popular tools being used across the globe for infrastructure automation. So this is nowadays one of the most popular tool in the field of infrastructure automation when it comes to DevOps, and has gained a lot of popularity because of the easiness of using the tool. And of course, it is open source and free. So HashiCorp provides you this tool as an open source. You can do your own changes and use it. Also, this is completely free. So when I say free, they have got different versions. Out of those offerings, I should say, they've got different offerings. One of the offerings is free, while you do have paid offerings as well, which we will see as we move ahead. So what is infrastructure as a code? Let's talk about, what infrastructure as a code brings more advantages. So I told you that infrastructure as a code is like writing our definition of creating our resources into a simple file. So what advantage that brings you is you can have a versioning of your infrastructure very easily in codes, in files. You have a descriptive model. The management becomes very simple. Okay. And if you have complex infrastructure, it can be easily managed using Terraform as well. And not just cloud, even any on-premises environment can also be easily defined and provisioned with infrastructure as a code approach. So there are many advantages whenever you need to make some regular adjustment to your infrastructure rather than going to the console and doing it manually. You can do it from the file and you can easily maintain the track that at what point of time what changes were done, so that if something goes wrong, if there is any stability or compatibility issue, you can easily roll back to the previous version. Okay, you have large amount of infrastructure as a service resources to manage. You are using different providers, so managing your infrastructure from the console of different providers can be really tricky and challenging. So if you have the same thing in a code, it becomes really easy to keep a track and do the changes whenever needed. And the best part is infrastructure as a code approach is used in DevOps. So you are collaborating two different teams, the development and the operation teams together. So they both are optimizing your infrastructure provisioning, working together. So one team is the one who develops your configuration and one who looks for operations. They both are working together in this approach. So if we try to summarize it in the form of a diagram, so let's say we have a team of developers who are writing our configuration in a code. Then in real time, if you are using infrastructure as a code approach, this code that has been written by developers can be immediately tested for syntax and other different types of errors. To maintain the version of this file can be stored on version controlling tool like GitHub, Bitbucket, and so on. And once everything looks good, you are happy, all the configurations are intact, you can share this file with your automation tool, whether that is any infrastructure automation tool. We are not talking about Terraform here, any tool. So then that tool will take those file and will connect to your mentioned provider, whether it is on cloud or whether it is on premises, and then your changes will be done accordingly. Your deployment will be done accordingly. So this is the different architectural components, I should say, or I should say different steps of action that are done in the infrastructure as a code approach. First, the developers write their configuration, then the configuration is tested and the versions are maintained if there are any updates done later on as per the feedback. Then once we are happy, we push that file or provide that file to our infrastructure as a code tool, automation tool. That tool, as per the configurations, connect to our plugin providers, our cloud providers or on-premises providers, and then do the deployment. Any questions till here? I think this is the right time to take the questions. If you have, you can go ahead, unmute yourself and you can ask. If not, you can give me a thumbs up. We will move ahead. Okay, perfect. Thank you, Joffrey. Thank you for that confirmation. Thank you, Ed, for that confirmation. So let's move ahead. And now, one thing you have to understand, whenever we are using infrastructure as a code approach, I told you that we write our configuration into our file. So the order of writing your configuration can matter if you are using imperative approach. Okay. So imperative approach is where you specify the steps, the action that will be done in sequence. All the steps are defined until you achieve what you want. And the tool that you are using to execute that particular file will follow your order. So you have to provide the every step that how my result will be achieved. That is called imperative approach. So you have to specify all the commands in appropriate order. If order is wrong given by you, then you might not achieve your desired result. On the other hand, there is also a declarative approach. In declarative approach, I does not care that in what order I write my configuration. I just keep writing all my configuration for my infrastructure. The order doesn't matter. My tool will automatically take care that which resource should be created first and then which one should come after that. That's called declarative approach. So the desired configuration is only mentioned here, what desired state you want. Okay. No matter how it will be achieved, that is the responsibility of complete infrastructure as a code tool that you are using. Okay. So most of the infrastructure as a code tools use declarative approach, and the same goes with Terraform as well. So some of them might be using imperative, some of them might be using declarative, but you will find that most of them are using declarative. From our topic point of view, Terraform uses declarative approach where the order doesn't matter. You just have to define your configuration and the resources will be automatically taken care by the Terraform. So this was all about infrastructure as a code. So now if I try to summarize the advantages, first, repeatability. I can repeat the same code again and again without the need of writing it again. Speed, the speed at which we can develop the configuration is very fast because now we are repeating it. So no need to invest time in rewriting the same configuration. We can have proper documentation. The version control of our configurations are easy to manage. You can validate toward testing and you can reuse those configuration files. So these are some of the major advantages that infrastructure as a code offers when you talk about this approach over manual approach of creating infrastructure. So there are different categories when we talk about infrastructure as a code tools. And these all category of tools, as you can see here, have different primary reason for what they are created. When we talk about the major classification under which you can say that how these are categorized, it mainly comes into provisioning and configuration. So from the right hand side, if you see here in provisioning, when we talk about provisioning, that means we are talking about creating our resources. And these tools that you see in the list, like Terraform, ARM, CloudFormation, these all are the tools that are used for creating infrastructure, not for configuration, just for creating those. While if you see the second in the list that talks about configuration management, this is about once your infrastructure is running, how you can configure that. Okay, how you can configure that. So here we have tools like Chef, Ansible, Puppet. These all are the tools that are used for management. They're not used for creating your infrastructure. They are used for configuring your infrastructure once they are created. We have a question in the chat from Barry. What is an example of an infrastructure as a code tool that uses the imperative approach? So very Ansible is right now, which I can show you on this slide deck, is one of the tool that uses imperative approach. Here, the order of your tasks in your playbook will define that how your tasks will be executed. Okay, so Ansible is one of them which uses imperative approach, where your YAML playbooks execute in the order you write your tasks. Coming back to our topic, so configuration management and provisioning. Okay, so first you will create your infrastructure using these tools. Once you have made your infrastructure, these tools, now if you want to configure your infrastructure, then in that case, you will use your configuration management tools. You will not use provisioning tools for configuration management and vice versa. Okay. Other thing that you are seeing here is also comes under the category of infrastructure as a code. Like if you want to create templates that could be helping you in running your infrastructure, then we have tools like Vagrant, Docker, Packet. Okay. Even ad hoc scripts that you can write. These scripts can also be categorized under infrastructure as a code because you are writing the code and you are automating your infrastructure creation, maybe installing some package after they are created. So these all scripts that you write comes also under the category of infrastructure as a code. So this is a high level categorization of infrastructure as a code. There are many other tools in the market, but these are some of the popular ones that you will see, you might come across. Out of these, now you might be wondering that, Akhil, we have got on this list 4 provisioning tool. Then what is Terraform? How it is different from others? Why are we only talking about Terraform? So of course there are differences, which we will see very soon. Let's talk about few of them, like Vagrant. This is used for templating. So you can create your templates for building and managing your virtual machines. And these are integrated with tools like Ansible, Chef, and Puppet for provisioning and configuring both. Then comes Terraform. So Terraform fully focus on only creating your infrastructure, creating, destroying, managing, not for configuration. Okay. So the entire focus of HashiCorp team when they made this tool was that this will go to help you in creating your infrastructure on your provider. And this uses HashiCorp configuration language tool. So you write your infrastructure as a code in HCL language, that stands for HashiCorp configuration language. There are different concepts like providers, provisioners, modules, and the workflow commands that we will see in the Terraform, and best suited for managing when you want to create, manage, destroy, update your resources. We use Terraform. Now, just like Terraform, we also have ARM that is also focused on creating your infrastructure components. Same way you have CloudFormation. But the difference is these tools are dedicated for only individual specific cloud providers. So I can use ARM only on Microsoft Azure. I can use CloudFormation only on AWS. I cannot use them on any other providers for creating or managing my infrastructure. While on the other hand, Terraform, one single tool, you can create and manage your infrastructure on 4,000 plus providers. Out of this, Azure, AWS, and these are very common providers that can help you to do that. Then you have Ansible. This comes under category of configuration management. So once you have created your infrastructure, you want to do some configuration like install some web server, some package, start some service, run some scripts. Then you can use infrastructure configuration management tools like Ansible, Chef, Puppet. All these comes under the configuration management. Different approach. For some of them are agentless, some of that are agent based, depending upon which one suits your working environment more. So if you see an overall category, overview of this, then Ansible, Chef, Salt Stack, these all are using declarative or imperative approach, mostly imperative. Puppet using declarative. Our Terraform tool that we're going to learn going to use declarative approach. The tool type, you can see the first four of them are under the category of configuration management. And Terraform comes under the category of provisioning, which uses HCL configuration language. So you write or manifest your code in HCL language, that stands for HashiCorp configuration language. While others, some of them are in YAML, some of them are in Ruby, DSL, and so on. So now this was a quick overview of different categories of infrastructure as a code tool. Now we will dive into the concept of Terraform. I can see we have a hand raised. Yes, Sean.
So the quick question is, in Ansible, let's say you have installed Nginx on a EC2 instance deployed by Terraform. Now, how are we going to update the Terraform scripts? Because next time you run that, Terraform may not know that this EC2 server has Nginx already installed.
Terraform will only track the EC2 instance creation metadata, not the configuration metadata. So what is happening inside EC2 instance is nothing to do with Terraform. So how that EC2 instance is running is what Terraform is taken care. What are the, AMI IDs and what are the instance type and all those things. Under that, what is happening is not. Sorry.
Yeah. So what I was going to say, so if I take the Terraform script from test to production, but in the test we installed Nginx and all, so Terraform is not covering that. So we have to do the whole Nginx install and all those things in the production, correct?
Using Ansible. Yep.
Oh God. Yeah.
Yes.
Yeah, that's a big, so Terraform and Ansible needs to be synced up all the time. Otherwise,
yep. So you need a provisioning and configuration tool together.
And Ansible does not have a provisioning options, correct?
Ansible is mainly used for configuration, not for provisioning. It's a configuration management tool.
Yeah, I got it. So I see the challenge there between these two tools that if you have it. But as a system administrator, because when we deploy EC2 instance, it's just not plain vanilla EC2 or VMware or container, because we will have to install several applications or web server or whatnot. That's through Ansible, but Terraform does not have any clue. So it's a infrastructure management is a nightmare at that point.
So Sean, there is one feature in Terraform. If your requirement is, for example, to install or run some services only once, not to take action on that again, then there is a feature in Terraform that comes under category of configuration called provisioners.
Okay.
If you remember, we discussed in our last session. Provisioners can help you not only create EC2 instance, but also of using Terraform, it will first create EC2 instance for you. And after that, with the help of provisioner, you can install web server, run your HTML files and host your web servers, start your services running directly. But again, it is only for one time. Once it is done, after that, if you try to change something, Terraform will not help. It's only like one setup task that you can achieve using Terraform.
Yeah, got you.
Okay.
Yeah, what about the patch management? That's also not done by Terraform.
No, not.
Oh, okay, got you. Thank you.
Yep, you're welcome. Okay, so moving ahead, now let's talk about the Terraform. So let's try to relate this, how Terraform is going to be different from other infrastructure provisioning tools. Like we have different cloud vendors in the market, okay, like Microsoft Azure, Amazon Web Services, Oracle, Google Cloud. These are some of the big giants in the market. And each one of have their own provisioning automation tools. Like if you talk about AWS, we have CloudFormation. If you talk about Microsoft Azure, we have ARM templates, Azure Resource Manager. If you talk about GCP, we have Google Cloud Resource Manager. If you talk about Oracle Cloud, we have a Resource Manager for Oracle OCI. So each cloud vendor has got their individual infrastructure provisioning tools. But as I told you, they are dedicated to only their own vendor, cannot help me to do it on others. So if my company is using a hybrid model where I have some resources running on Azure, some on AWS, then if I have to create and manage my infrastructure, I need two different skill sets. I need two different set of teams, two different employee working for me, having exposure to two different tools. But what if I bring on the table Terraform? Terraform solves your problem of creating resource on any of these vendors. So you get one person who know or one team who know working on Terraform. Just give them the requirement of different vendors wherever you want your infrastructure, and it will solve your problem. So managing multiple resources on different vendors is what Terraform offers you. And that is why it is gaining popularity, because with the help of one tool, I can create infrastructure on different providers and manage them, which will lead to many advantages, like time to build my infrastructure will be fast. Human errors will be less because only one person or one team working on one skill set, one code, one infrastructure as a code tool. You can track the changes easily. You can replicate, rebuild, and manage your multiple resources. So overall, if you see, what all Terraform offers. So this is going to be a quick summary of what all topics we are going to cover in this training. We will talk about providers in Terraform, what are resources in Terraform, what are configuration files of Terraform, the variables, the state files, the data sources, the modules, the workspace. So these all topics, sorry, the provisioners, the security in Terraform, the Terraform enterprise, what are the best practices. So all of these concepts is what we are going to see in this Terraform. Just excuse me, everyone, for a minute. Sorry. Sorry for that interruption. Okay. So yeah, so I was saying that this is the overview of Terraform that we are going to talk about. That in Terraform, what are providers, what are resources, the configuration files, and other things. So now let's talk about the Terraform, that how Terraform actually works. So in this slide, what we are trying to explain is the cycle, the workflow, how you start writing your Terraform configuration files. So the first thing as a developer that you will do is you will write different Terraform configuration files, .tf. All the Terraform files, the HCL language that you will use will be ending with .tf extension, .tf. Okay. Then there are some other extensions you might be seeing here, but what are those? I will tell you tomorrow as we move ahead. So everything is ending with .tf. So you first write your configuration, which will be provided to Terraform tool. And then Terraform will connect to your provider, whichever provider you want to create your infrastructure. And then your resources will be created. The motive from this slide is to explain that you don't need different set of files, extension files for different provider. That if it is AWS, I will have a different .extension file. If it is Azure, a different .file. No, any provider doesn't matter. All of them will have same language, same extension. Only thing will change is, like, for example, resource name will change when you will write a configuration, right? For example, a virtual machine is named as instance in AWS, while it is named as virtual machine in Azure. VCP in AWS, VNet in Azure, S3 bucket there, storage account there. So the resources names will change, while rest of the syntax, the configuration, the extension, everything will remain same, no matter what provider you are using. So from this training, you are going to achieve the skill set of writing Terraform configurations, not only for any specific provider, but you can do it for any provider. Although for demo, lab, and task, we will be using only one provider in this, that is Amazon Web Services, AWS. While on the other hand, for each task that I will do, we have recorded videos if you want to practice it. For example, if I'm telling you an example of a concept on AWS, then similar to that example is uploaded for Microsoft Azure as well on your K21 dashboard, where you can go ahead and explore and also practice in parallel after the session. But in this live, because we cannot take multiple providers, it will bring a lot of confusion in our configuration files, and also keeping the content and time frame in mind, we always take one provider at a time, while the other providers example and other things are provided via recording. Like the previous in which Sean was available was for Microsoft Azure. This one we are going to cover Amazon Web Services. So it keeps on switching, but you can use it for anything. So you don't keep it in mind that Akhil is going to train us to use Terraform for AWS only. No, I am going to share my experience of writing a configuration file with the proper syntax for any provider. I will take example of AWS, but the same example will be applied for other providers also. Here and there in between, I will definitely give examples that how it relates and how it looks in other configuration files, so that you will get a clear picture as well. Jofi, I can understand you're looking to work on Azure more, but rest assured, you will get both Azure, AWS, as well as other providers also. It's just that in this live session, you will see the demos and labs, everything being done on AWS, but you have an advantage because you can see live for AWS, and then you can go to your K21 dashboard and you can also access the recording for Azure and then come up with doubts that, hey, this was how we did in AWS and this is how I did in Azure. So if I have a question, how it can be resolved. So the team, or if taken in the live session, I can help you with that as well. And this is for others also. If you're looking for GCP or OCI or Alibaba or anything else, rest assured, this training is not for AWS specific. This is just a Terraform training. It's just for example, for demo and labs. We are taking one provider, that is AWS, in the series, just for the practice tasks. Having said that, let's move ahead. A quick summary of Terraform. So I told you it's an open source written in Go language, used for building your infrastructure. All the configuration files are in HCL language. You can manage your cloud vendor or even on-premises platforms using Terraform. Configuration files will be in .tf extension. Terraform will create plans and you can use those plans to reach your desired infrastructure that you want. This is responsible only for creation. Again, I am pointing it out. Terraform is responsible for creation of your server, your resources, your services. Manages low level and high level of components, meaning whether you talk about different components when it goes to cloud vendors, then we have different high level and low level components. High level components we talk about when we are talking about the overall architecture, especially when we talk about the business models and the policy decisions. At that point of time, we talk about high level, and low level, you can think of small components and services like compute, storage, networking. Okay, so these all comes under the low level components. and high-level components, as I said, your DNS entries, your policies, okay, your software policies, features, all these comes under the high level. So it manages both of those. It's just that you have to understand how the configuration files are defined. Support for multi-cloud. I told you that it is cloud agnostic, so it can be really helpful to create on different providers, almost all providers in the market. One common tool to be used across multiple clouds and services. That's the benefit that we get. Okay. Then comes the concept of mutable and immutable. So if I go back some slides back, then there was a slide where we did a comparison that Terraform is immutable infrastructure. Now, what does this immutable means? Let's talk about this. It's based upon, the modifications that you are doing to your resource. So if I am saying mutable infrastructure, so let's say that today you created one virtual machine with V1 version. Now tomorrow, if you are trying to do some changes on that same and making it V2, it can be done directly. So V1 will directly update to V2 and your changes will apply. That is called mutable, where you can change the configuration on the go to the same infrastructure that is running. Immutable means you cannot do the changes on the live infrastructure. That's immutable. So if you have V1, if you want to bring some updates as V2, you will have to first of all create a provisioners, your resources with new updates and then delete the older one. That is called immutable approach. So a new infrastructure is provisioned when we are using immutable approach, while immutable, the same infrastructure is updated. Okay. So Terraform works on the immutable approach. So just now, a few minutes back, Ansible and Terraform discussion was going on between me and Sean. And this is what comes here, that both of these tools in any production environment, you will see them working hand in hand, Terraform and Ansible. Because we are not limited to any one requirement of only provisioning or configuration, right? Once they have created any resource, they will be needing a configuration of that resource, which we use with configuration management tools. So if you see this example, first the developer writes the configuration file to create my infrastructure, give it to Terraform. Terraform connects to my provider, for example, AWS, creates my EC2 instance. Once my EC2 is created, the information of this EC2 is given back to Terraform, which stores in a file, and this file is shared with Ansible. So now Ansible can fetch the details of the EC2 instance from this file, and then using those details, Ansible connects to EC2 instance and do all those changes that you have defined in your playbooks. So this is the flow, how the provisioning and configuration management works together. Any questions still here? You can ask me now. I'll take a pause for a minute. And if you have any questions, you can ask me here.
So, Akhil, what I'm hearing that basically this is exactly what I was looking for in the past, that we can upload Terraform.tf state file to Ansible, and Ansible can read and understand that file and continue to do the configuration management or whatnot, correct?
So, Sean, it depends how you want to share your infrastructure information with Ansible, because TF state file contains the entire infrastructure information. So it is always not a good idea to share this entire file with Ansible. Ansible only needs the inventory details, right? Like what is the IP address of this machine and what is the username and password to connect to this machine. So it's not good idea to share all other not useful information for Ansible, which might be a loophole. So instead of doing that, you create a separate file and you store only information which Ansible wants. For example, username, password, or a token, or whatever it may be, the public IP and the private IP. And you share this file with the Ansible. And this file that you are creating, maybe you create this as an inventory file directly for Ansible as .yaml or whatever you want. So this file will be created by Terraform once my resource is created, and this file made by Terraform shared to Ansible. So this file keeps on updating with the information which Ansible wants only to keep it updated so that it can connect to my provider. So this
And
action is done by Terraform here.
oh wow, so it's not manual process. So what is that name of the file? What is the dot
So
extension?
this is which I told you, right? Provisioners.
Okay.
This is where provisioners can help you. So provisioner
Okay.
will help you to create this file and provide you the information that you want to share to any configuration management tool.
Gotcha. Makes sense.
Yep.
Thank you.
Welcome.
Atil, I have a question over here, please.
Yes.
Yes. Okay. You mentioned that regarding the in case if the organization have multiple cloud provider like GCP, Google, and Microsoft Azure, and the for to hire the right a Terraform engineer. So the engineer, should he have an experience in all these, or just only it's enough to have an experience in Terraform and that's it?
So Salim, if we are looking for the skill set of Terraform, we only want the individual to have Terraform experience, because we don't want the person to have experience with all these cloud providers, because it will be the responsibility of the respective team members that based upon requirement, you share the requirement to the team, and then that person will take care of creating that resource. The person don't need to know what is EC2 instance or what is VPC or what is security groups. The person just need to know that you want me to create EC2. I need these details. Like I need the name, I need the AMI ID, and I need this. So you tell me that what should I use? That's it. And then let me do my job. The person don't need to know what is VNet, what is S3 bucket. The person just need to know that, Salim, if you want me to create an S3 bucket, tell me what bucket name you want. Do you want any bucket name? Tell me that name. That's it. I will create it for you. So if any organization is looking for a skill set of Terraform, they will be least bothered about having exposure to all the cloud providers. Of course, they might, give a advantage if you have exposure to one or two of them, at least as an administrator level, so that it's good for you, that you know about what resource you are deploying, but that is not mandatory.
Yeah, but on the vice versa, okay, what I'm seeing in all the job postings, that Terraform is an add-on or mandatory requirement for AWS or Azure Cloud Architect or DevOps engineer. It's like you have to know the cloud well, and then add the Terraform skill, because they're not hiring just a Terraform guy. I mean, at least I haven't seen it, but I could be wrong. So nowadays employers are asking a lot from one person. If you are an architect, you need to know Terraform and you need to know Ansible, right? You know what I'm saying?
Yep, Sean, definitely. So the job profile that you are explaining is about an architect, which definitely needs an idea about what plan you have to do for resources. But
Right.
if we talk about the job roles where we are dedicatedly looking for infrastructure as a code engineers, DevOps engineers, there we will not have those as a primary skill set. They will be definitely there, as you mentioned, but not primarily. Of course, as an add-on, if you have if they are working on AWS or Azure, and if you have that, it's a cherry on the cake for them. Otherwise, they are looking for the DevOps guy, those who have skill set with working on infrastructure as a code tools like Ansible or Kubernetes or Terraform. Okay.
Sorry, Akil. Did you suggest that Terraform is mutable or is it immutable? And I just wanted to know which one are you saying?
Terraform is immutable infrastructure approach.
Okay, so that
Yep.
means that once you deploy the services, you might not be able to use Terraform to make changes.
Yes, so whenever you do any changes, it will recreate and replace instead of doing update in place.
Right, so it will destroy what you already have and recreate it again.
Correct. Yes.
Okay.
While
I
tools
have-
like, Chef, Ansible, Puppet, these all are mutable, but Terraform is an immutable infrastructure.
which is great. So I have a quick question from the security standpoint.
Yeah.
Is Terraform encrypted? Like if the hacker hacks my Terraform environment and they can get all the informations, and I'm like in a big trouble. How's the security aspect of Terraform? That getting saving a TF state file in an encrypted format. How do you protect those from the hackers?
So, Sean, we will discuss about that, but since we have asked here, I'll give you a small hint.
Sure.
The state file that maintains the infrastructure information, we don't keep it, locally or exposed. We
Oh, got it.
always store the state file in a remote backend, which is
Mhm.
highly secure, maybe in
Yep.
S3 bucket, Google bucket, storage account, or any
Got it.
remote URL. So
Yeah,
we do
makes
have
sense.
a topic where we will see how remote backends are used and configured. There you
Right.
will get a clear picture that how the state files are shifted from your local machines to the remote machines.
Awesome. Yeah, that makes sense. Thank you. Yeah, I got it.
Yep. You're welcome. Perfect.
Akil,
So,
sorry.
yeah, sorry. Yes.
Okay, sorry, I was just going to say that. So if it was a system or an environment whereby there will be several changes going on, that means Terraform would not be the right thing to use then.
Nope, not at all.
Okay.
That is why Terraform is only for provisioning, not for configuration later on. And even if you have done provisioning and if you are doing changes to the, resources metadata, like you are changing the name, you're changing the IP address, then Terraform will recreate that. So you have to be careful. It might create a downtime to your customers. So the step should be taken very wisely.
Okay, thank you.
Yep.
Aqil, a quick question here.
Yeah.
Since the Terraform engineer, what I understand from you, correct me if I understand it wrongly. So he's just only adding a value for our an organization that who has multiple ISPs or cloud providers, not just only as in a single cloud provider. Am I right?
Correct. Yes, Salim.
Okay. In this case, like example, so in case we are either into Azure, so I believe the ARM template that can replace the Terraform engineer with easily. So there's no need to recruit any Terraform engineer. Isn't
Correct.
it?
So yeah, if you are not only just using Azure, using some other, it will be more add-on. But if your platform is completely only on Azure, not using any other provider, then in that case, using ARM templates are more secure and safe. But the moment you go to hybrid, you want to switch to hybrid cloud. And in that case, instead of getting another person with a skill set of cloud formation, you can give a shot at Terraform engineer who is better with one skill set, helping us to provision my infrastructure on both the cloud providers.
Great.
Okay.
Great. Thank you.
You're welcome. So on that note, team, we finished this first module. It's the overall summary. We discussed about infrastructure as a code, advantage, the stack of tools, the benefits, the cloud benefits, the architecture, and how Terraform works. So we end our first module. Now the next one is about Terraform installation and the lab setup. So let's go ahead and start that. So I'll take a pause for 5 minutes, team. Just excuse me. I'll be back within 5 minutes and then we will start the lab. Meanwhile, I will request all of you to open AWS Amazon Web Console. If you have your personal accounts, please log in. If not, please create a free account on AWS console. Don't use your any official accounts for this lab, for this training. You can create a free account. We will not be creating any resource which will incur us any charges because we will keep a track of destroying them at the end. So do that and then we'll move ahead. Allow me 5 minutes. I'll be back. Thank you. Okay, thank you for waiting, everyone. So let's get back. So the first thing that I'm going to do is sharing my screen. Okay. So I'm creating an Etherpad where we are going to share our all the lab tasks. So I'm giving this name as K21 June AWS. And I'm sharing this Etherpad link in the chat window. This is like an online notepad that is shared to all of us. And we all can edit this at the same time. So we will use this for our lab documentation and tasks. So when it comes to the lab setup and Terraform installation, the first thing that we do is download Terraform. So to download Terraform, you can go to Google. I'm sharing the link directly. So this is the page from where you're going to start the downloading. On this page, select Windows. You can go for 386 or AMD 64. Any of these is fine. You can select whichever you want. And along with this, we will also download editor. If you have, you can use your existing. So we are going to use a VS Code editor. So this is the URL from where you can download the VS Code for your respected OS. And then we will, that's it. We only need these two tools, nothing else. And then of course, log into AWS console. So let me also start this setup. So opening the Etherpad link in my machine. Take it from the chat window. There we go. Now from here, I can easily download these. Just removing these colors, the first option, authorship colors. Zoom this a bit. First, I need to download in Terraform. So selecting any of these can be fine. I'm going for the first one. It will download a zip folder. And then let's download the Visual Studio Code also for Windows. So first thing is VS Code setup. I will run the setup file, the installer file for VS Code. This is a direct installer, so there is no much difference as compared to normal installer. Just click on OK and then next. I accept the argument. Next. You can select if you want a desktop icon. Next, and then install. It will hardly take a minute to install. Okay, done. So VS Code is done. Now let's go for Terraform installation. So for Terraform installation, what you have to do is in your downloads, you have got this zipped folder, a compressed folder. First, you need to extract it. So right click and extract. You can extract it in any location. I'll go with the same location. And once this is extracted, you will see a folder, extracted folder will appear on the same location because I have not chosen any other location. And from this file, the extracted folder, there is a file called Terraform and license. So you just copy. Joffy, you can download any of the version. Either you can download AMD or 386. These are architectures. Just anything is fine. Both of them are compatible.
Yeah, what I was just trying to ask you, we have an AWS, and AWS, on that AWS we need Windows, right? Some configurations of Windows need to be there in order to install this Visual Studio as well as this Terraform, right? So did we talk on the?
No, why do we need it on AWS? Nothing. On AWS, we will create resources using Terraform. Okay. So we will install this Terraform in our local machine.
Oh, okay.
And a VS Code in our local machine.
Oh,
okay. Yeah. And then using this Terraform, writing configuration on VS Code, we will create our resources on AWS console. So now I'm also going to log in AWS console. Okay, so now this is my console. So here I'm going to create nothing to do here on console right now. I will create resources here using Terraform. First, we will set up our Terraform. And for setting up Terraform, we have got this folder, zipped folder downloaded. We have extracted the folder. And now from this folder, we have got this file, Terraform application file. We will copy this file and in any directory, prefer C drive. In C drive, create a new folder named as, let's say, Terraform. And inside this Terraform folder, paste your application file. So after extracting your Terraform zipped folder, copy the application file from that folder and paste it in a separate new folder named as Terraform on C drive. Once you have done, now copy the path of this current directory where you have pasted your application file, which will be just C:\Terraform. Copy this path and open your environment variable settings. Go to search and type there env. You will see a setting displayed from the control panel as edit the system environment variables. Open that. From the new window, select environment variables from the bottom. Another window will open from where at the top you will see a variable named as path. Select that variable path and click on edit. This will open third window. Click on new and paste the path that you have copied. I'll wait for a minute here. Open environment variables by searching for env in the start menu. You will see a matching result called edit system environment variables. And then go to environment variables, select path and click on new and paste the path that you have copied. For file extraction, you just have to right click and click on extract all. So in downloads, just select your folder, right click and click on extract all. And once it is extracted, you will see another same folder name, which will not be a zipped folder. So in there, you will open that folder, the extracted one, and select this application file, Terraform file. Once you have selected this file, now go to your C drive, open your C drive and create a folder, new folder named as Terraform. And inside this folder, paste the application file that you have copied. Once you have copied this, pasted this file here in the newly folder. Now from the top, from the address bar, you can click on the blank space after Terraform. It will give you the complete address. Copy this address. Control C, copy this address. And now go to search menu of your taskbar and look for env. The moment you type env, you will get a matching result called edit the system environment variables from control panel. Click on this settings. It will open this window, which will ask you to edit system properties. In here at the bottom, you have the option environment variables. Select that. This will open a new window where you will see at the top user variables for your username. Select the variable named as path. And click on edit. And once you click on edit, the third window will open where you will click on new and then paste the path that you have copied, C:\Terraform. And then click on OK, OK, OK. Do not cancel the window. Click on OK, OK, OK in a sequence to close the windows. This will apply these changes. Once these changes are applied, everyone, how will you confirm the installation? Open your command prompt. Open your command prompt. And in command prompt, type the command Terraform -v and press enter. This command should give you the Terraform version that you have installed. Perfect. So everybody take your time and give me confirmation once you have done this installation. Barry, Joffy, and all other participants. I hope Sean has already finished. So remaining others, please give me a confirmation in the chat. These are the graphical instructions, so I don't have anywhere written. If you want me to repeat, you can let me know. First give it a try. Try following the instructions as I told. Try recalling them. In case if you are stuck somewhere, you can let me know. You can even share your screen. I can help you there. Thank you, Joffy, for confirming. I'll appreciate others also to give me confirmation one by one. Yep, if you have any doubt and if you feel that it can be done quickly with the help, then you can let me know. I will be happy to do that.
Hey, Akhil, can you please repeat the last step? The environment variables, we have to pick the new.
Yeah, so you open the environment variable settings, env, and when you go to the environment variables, the variable named as path from the user variable, select that, click on edit, and then here in the new window, you click on new and paste the path that you have copied, C:\Terraform. And then click on OK to close all these windows one by one.
Okay, thank you.
And then test it on the command terminal by using Terraform-V command.
Yeah, Akhil, I have one question. Can I ask you now?
Yeah, please go ahead, Joffrey.
Yeah, you see, if I just try to install on my local machine, is it a better choice that to get more latency so that I'll be install this on the AWS and have a minimum Windows machine and then install this Visual Code and uh, the Visual Code as well as this Terraform on that system?
I will recommend Joffrey do it on your local machine. It will be fast and you will have the track of all the files that you are testing and performing, because it's just a very lightweight application to install VS Code. And then Terraform, we are not installing, we are just giving the environment variable path for our application to run. So I will recommend you doing it on your local machine.
Okay, then connecting to that provider.
Yeah. Yes, you can share your screen. I'll stop sharing my screen. And I'll give permission. Yep, you have permission. You can go ahead. Okay, we can see your screen. Yep. This is the extracted folder, I hope. Can you go back to downloads once if you're comfortable? Thank you. Yep, looks good. Open the same folder again. Yeah, copy the Terraform file. Okay, now go to C drive. Yep, and yep, okay. Paste the file here. Okay, now from the top address bar, copy the address. Yeah, click on this, Control C. Now go to start and type env. Env. Wait for matching results to come. Okay, don't see that still. Can you try again? Please go to search. Type in search box env. System is not responding. You can try opening control panel. From there you can go. Don't press enter. Wait for some time after pressing env. Type env and then wait. Do not press enter. Yeah, wait. Let's see if it matches the result and give us something. No. So we need to open the system settings. Look for a way to do that. Otherwise, it won't allow you to do, because we need to put our path that you have copied. Try going to start menu and search for control panel. Click on Microsoft Windows icon. The step for downloading the applications are given in the Etherpad. If you want, you can try restarting your system. Maybe that might help, because I see that your system is not responding properly. So just if you want, because we are going for a short break now. So you have 15 to 20 minutes. So
Okay.
just restart your system and see if you can open the environment variables. Okay.
Okay. All right. Thank you.
Yep. You're welcome. Okay, everyone. So I see some of you have already done it. That's great. Some of you are still doing it. We will make sure that everybody has done this before we move ahead. So in case if anybody needs help, we will come back after break and we will try to first get it resolved and make sure that everybody is on the same page, and then we will move ahead. Okay, so go ahead, everyone. Enjoy your break. We'll get back after 20. I'm going to run a timer. And once the timer runs out, we will resume our session. So allow me a minute. Da-da-da. So we are almost done with the installation. Now it's just that we have to set up our AWS authentication. Welcome back, everyone. Hope everybody is back from break. Okay, so thank you for confirming. You got two environment variables. So now you just need to go to this environment variable, then select path, click on edit, then click on new and paste C:\Terraform. Your Terraform T will be in uppercase because that is what name you have given. So keep it same and click on OK. I hope others also have completed, because once we are done with this, we will move to next step, that is about the authentication. Yes.
Akil,
Yes.
sorry to bring you guys back. Sorry. I got to
No problem.
environment variable
Okay.
and I got to path. So if I click on path, do I click edit?
Yes.
Okay.
After selecting path, click on edit.
Yes, edit. There's a user profile / app data, and then you have new edit, browse.
Yeah. So click on new
New. Okay.
and then paste the directory path that you have copied.
Okay, which is C/Terraform. Yeah.
Yes. Then
And then
click on OK, OK, OK. All windows close.
okay. Right. Got it. Thank you.
Yep. You're welcome. Once we are done, to confirm your setup installation, open your command prompt, CMD, and run the command Terraform --V. This command should give you the output of your Terraform version.
CMD, and then why is it so small? Okay. And then Terraform
--V.
Space hyphen V. All right, it just says Terraform V 1.9.0 on Windows AMD 64. Is that what we're looking for?
Yep. Perfect.
Okay, thank you. Let me go back to
Good. So that is also done. What about you got your environment variable? Are you able to fetch the version?
Sorry, I didn't get that, Akil.
No, you are done. I'm talking about another user.
Oh yeah, on my own laptop, I couldn't because I would need an administrative access, so I couldn't.
Correct. Yeah. You will need admin access.
Yeah. So I could do that later on. That's fine.
Okay, fine. Perfect. So I hope everybody is okay now, so we can move to the next topic. So now we are talking about next thing, that is Terraform installation is done. We have got our VS Code. So everybody open your VS Code now. You can open your VS Code from the shortcut icon if you have, or you can start it from the start menu. Launch your VS Code. This is how you will see at the launch of VS Code. It might ask you to select a theme. You can go with any theme of your choice, dark, or you want light theme. It's totally your call. I will go with dark theme so that the characters are quite visible to all of you. So keeping it dark, click on mark done so that you don't get this option to set up your theme again. Once you click on done, it will ask you to start creating new files and writing your configuration. So here, before you start writing the configuration, let me explain about this editor a bit. Some of you might be new to this. In the left-hand side, you can see there are tools that helps you to search, add extension, okay, and do source control. And at the top, you have menu bar where you can do editing, selection, view, open terminal, and so on. So from the top, this is the option which will be your go-to option, terminal. Open terminal and click on new terminal. This will launch inbuilt terminal in VS Code. So you will not need to open command prompt separately. So click on new terminal and it will launch the terminal at the bottom, as you can see. Okay. Here you can again test whether your Terraform command is working fine. So Terraform space -v and the Terraform version is listed here. Now what we will do is we will create one folder on desktop, new folder, give this name as K21 Terraform. This folder is made on desktop. You can create it anywhere of your choice. I am creating on desktop for easily accessing the directory. Once you have made that folder, now what you will do is on your VS Code in file menu, go to open folder. And navigate to desktop and select the folder that you have just created. Do not open that folder. Select the folder that you created and click on select folder. Your entire VS Code workspace will change to that folder. You will get a message. Do you trust the author? Say yes. And in left hand side, you can see your folder name is listed. K21TF, the same that you created on desktop. And here, if you launch the terminal now, you will see the working directory of terminal will be in the same folder that you have created, K21 Terraform. Give me a thumbs up once all of you have done till here. And if you have any doubt, anywhere you missed, you want me to repeat?
Please, can you
Okay.
repeat it?
Yeah. So first, you create one folder anywhere of your choice. Maybe let's say on desktop. You can use any name, whatever name you want. This is just we are doing some proper file management so that we can easily access the files. So I made it on desktop. And then open your VS Code and click on file. Then go to open folder. Now this we are doing in VS Code, file, open folder, and then navigate to desktop from the left hand side and select the folder that you have just created and click on select folder. This will open your VS Code. You might get a message to confirm. Confirm yes. And then you can see that in left hand side, your folder is listed. You can open the terminal and you will see your terminal is also in your working directory. I believe everybody has done till here. Now, next thing we will do is, now let me start sharing my presentation. Module number 2. I hope by now all of you have your AWS account ready. In case if it is not, make sure that in our before next session, you have it ready so that we can save time on that. Okay, there we go. So next module, in this module, we are going to talk about, we have finished our installation. We will mainly talk about providers and some Terraform workflow commands. What are providers? How do we define providers? We will discuss about this in this particular module. So let's get started. First thing is we have finished the installation. Terraform is available for Windows, for Mac, for Linux. We have binaries and packages available for different operating systems, as I showed you on the official downloads page. You can download it as per your operating system and use it. For Linux, you can download it or you can use your package manager. Same way you can do it for Mac and for Windows. You get the application file, you set up an environment variable, and then you are all set. We use an editor. VS Code editor is used in this session. It's not mandatory. You can use any editor of your choice when you want to write your configuration files. Sorry, somebody saying something? Okay, I was saying you can use any editor of your choice. VS Code we are using here because it provides extension that can make our life simple with syntax highlighting and IntelliSense feature. You can use Notepad++ or any other editors also to write to configuration files. It's just we need a tool to write our configuration. That's it. Then now the next thing that we have to talk about is the plugins. Now let's try to understand actually how the plugin architecture is going to work. So what happens in Terraform when you are trying to connect to your provider? Basically, when I say provider, it means the platform where you want to create your infrastructure. So it's simple. You want to connect to your infrastructure from your local machine, right? So first thing that you need is you need a Terraform in your machine. So you will download this that already we have done. You will get this binary from HashiCorp official for your respective operating system. Now this application file that you have downloaded, this needs to connect to your plugin. Okay, so plugin is like a local application file that you will download for this with respect to your provider that will allow you to connect to your cloud provider. And these plugins are available from HashiCorp. We have separate plugins for separate provider. So if you are planning to connect to AWS, the plugin will be separate. If you're planning to connect to Microsoft Azure, the plugin will be separate. So you will have to download this plugin. So Terraform application file and this plugin, they both has communication, secure connection and communication using remote procedure calls, RPC connections. So once you have got this plugin from HashiCorp downloaded, that we will do now next topic. So till now we have only done step number 1. We have got Terraform installed. But now we need this plugin. This plugin will be responsible in order to connect to our provider. Okay. And this plugin will be available from HashiCorp. Again, we will download this, which is again written in Go language. Then this plugin will connect to your cloud vendor using the APIs. So this is how the communication happens, the architecture happens between your Terraform running on local machine to the cloud vendor where you want to create your infrastructure. So there are 3 requirements. Requirement number 1, you need Terraform binaries that we have all done. Requirement number 2, binaries are not sufficient to connect to provider. We need plugins, which are libraries from HashiCorp, and each provider has got their own plugins. So for AWS, you will download your provider, and then that plugin written in Go language will connect to the cloud vendor over the secure connection. So this is the entire communication flow that happens from local machine to the remote API of the vendor. Okay. So these plugins that we are talking about now that we are going to download is written in Go programming language. And these are distributed by HashiCorp, automatically installed and maintained by Terraform. You don't have to do anything. You just have to tell that which plugin you want, and Terraform will take care of that downloading and maintaining that. and every provider has got their own plugins, and these plugins are responsible for communication with Terraform as well as with your cloud vendor API both. Now, once we have these plugins, the next thing will come into picture is providers. Provider is actually where you want to create your infrastructure. In this example, we will take AWS, it can be Azure, it can be Google, anything. So you need to define that first thing, that which provider you want. Then based upon that definition of your provider, it will download the plugin. Once plugin is downloaded, you will have to define that how authentication will be done. Then authentication mechanism has to be defined there. And these all is done under provider block. So we define provider block, which will tell that which plugin we want and where do we need to create our infrastructure. And under this, we will define our authentication mechanism also. So we have different types of providers, AWS, Azure, and we have seen a lot of them. Now, where are all these providers and plugins available? Let me show you that. So now your go-to page where Terraform stores everything is registry.terraform.io. Registry.terraform.io. This is the Terraform registry page where Terraform stores everything, all the plugins, libraries, everything. Registry.terraform.io. I'm going to put this on the Etherpad so that all of you can access this whenever you want to go to this page. Terraform registry. There we go. So if you see on this page, the very first option that says browse providers, you see how many providers we have? 4,291 providers till to date. That means I can create infrastructure using Terraform on these number of providers. So if you open the first option, browse providers, you will see the list of names of all the providers, where you will see at the top some big giants in the market like AWS, Azure, Google Cloud, Kubernetes, Alibaba, Oracle, and so on. So all these are providers. What are providers? Providers are actually an abstraction of API, which are responsible for interaction with your vendor as well as with your local Terraform. So you want to use any providers, the method will be same. How? Let's see now. So now we are going to create our first file. And how do we do that? In our current folder, K21TF, you have this file icon, this first file icon. You can click on this, or you can click on new file. There are different ways. So you can click on this first file icon, give it the file name. For example, you can give it a name as file1.tf. Or, I'll say first file.tf. First file.tf. .tf, Terraform extension. Okay, .tf, Terraform extension. All the configuration files that you will write will have .tf extension. Remember this. Now, since we are working with TF extension and we are using VS Code, let's use this features of VS Code where it provides us an extension. So if you see on the left-hand side, there is an option, the last option, that is extensions. So we can click on that and search for an extension here named as Terraform. Terraform. When you search for an extensions Terraform, you get the first result from HashiCorp. There are many results matching Terraform keyword. We are looking for a result from HashiCorp having most downloads, 4 million downloads. So if you install this, it will hardly take 2 to 3 seconds to install. So if you install this, it is done. And again, if from the left hand side, click on this Explorer and go to your file. Now, whatever you will write, that extension will provide us the syntax highlighting, color highlighting, IntelliSense feature with .tf, what are the declared attributes and arguments. So all this help will be provided from this extension. Now, how we do that? In HCL language, we write all the configurations in blocks. So there are blocks of configurations. The complete HCL language is made up of blocks only. Okay, there's nothing else than blocks, only just blocks. So the first block that we're going to talk about is provider. Provider. So provider is a block that will define your provider definition, that which provider you want to create your resource. So you say provider and then space, in double quotes, you provide your provider name. So let's say my provider name in this case is AWS. So you provide your provider name. And then after provider name in double quotes, you provide opening and closing brackets, curly brackets, under which you will define your provider configuration. So every block is name of block, block name, and then block configurations. This is how you write your entire HCL language. Block, block name, and then the configurations. Like in case you're working with Microsoft Azure, then it will just change to provider Azure. If you're working with Google, provider Google. Now, the question is, Akhil, how will I get to know that what is the provider name? Because let's say for Google Cloud Platform, it might be GCP. It might be only Google. So how will I get to know that what is my provider name? So you will go to this Terraform registry here. Whichever provider you want to create. For example, right now we are interested in AWS. So select that provider. You will see the provider name which you have to use, AWS. For example, if you want to go to Azure, so provider name for Azure is Azure RM, not just Azure. It's Azure RM. RM stands for Resource Manager. Same way if you go for Google. So this is just Google. Only Google. If you go for Oracle, it is OCI. So you will have to check from here if you are working on a new provider that what is going to be the provider name. Okay, makes sense. Now, question is, Akhil, as a beginner, how will I get to know that this is the syntax? provider and then provider this and then this. It's very confusing for me. So again, Terraform registry is your rescue. In Terraform registry, go to your provider. And on this page, right-hand side, you have an option called use provider. Use provider. So if you click on use provider, it will show you a drop-down result where you will see at the bottom, you have the block, how to define provider AWS. And then in this, you will write some configurations. You go for any one, like for example, for Azure, use provider, again, see same thing. So from here, you can always see the syntax that how my provider definition has to be defined. For Oracle, again, I'll go here, use provider, provider OCI. You have to ignore this as of now. What is this? I will tell you maybe in second or third day tomorrow, or maybe next class to that. As of now, just understand the last bit, provider block. So we have defined our provider, AWS. After defining your provider, as of now, we are not giving any configurations. Let's leave it empty because there are some default configurations always. So if you want, you can ignore them and let it go with the default values, or else you can override them. So we will provide some configurations later on. As of now, let's go with the default one. So after writing only this 2 lines of code, save your file, Control S. You can also go to file and save. Once your file is saved, open your terminal. And on your terminal, now you will run the first command that will download the plugin. So now we need the plugin, and we have told to Terraform that I want plugin for AWS. So how will I get the plugin? I will use Terraform init command. So Terraform init. Terraform init. This command will download the plugin in your current working directory. So right now you see in this folder, I only have one file, first file. The moment I will run init and hit enter, you will see some files getting created automatically by Terraform, and those files will contain my plugin information. So let's hit enter and see what happens. You can see it says initializing backend, initializing provider plugins, finding latest version of HashiCorp AWS because I have provided AWS in my configuration file. Installing, and then it gives a message something, and then it says Terraform has been successfully initialized. So if you see it on the left hand side, we have got some files created here the moment this command was successfully executed. One folder and one file. What is that folder? I will show you. So this is my desktop where I created K21 TF. And there is a folder called .terraform which has been created automatically by Terraform. If you open this .terraform folder, you see we have a folder called providers, which again contains a folder name as registry.terraform.io. That is the same my website, registry website URL, registry.terraform.io. After that, it contains HashiCorp. Then it contains the provider name, that is AWS, followed by version 5.56. We have not given any version, so it automatically went for the latest one. And then inside this, we have the architecture 386, and then it contains the application file. So this is the application file, the plugin, which is actually used to have communication with my vendor and with the Terraform both. So you see how Terraform maintains the directory structure. .terraform, providers, registry, HashiCorp, AWS, version, architecture, which contains my application. All of you go ahead and run this command and let me know if you have got your providers downloaded or not. And then if you have any questions, you can ask me.
Yeah, again, I have a question.
Yes,
I
go
ran
ahead.
the command Terraform init, but it did not create the folder and the files. But I got the message Terraform has been successfully initialized.
No, that means your file is not saved. Please save your file and then run the command.
Okay. Okay.
Yeah.
Yeah, got it. Yeah, thank you.
You got the folders now?
Yes.
Yeah. So the file should be saved before running any Terraform command. Okay.
Okay. Thank
Yeah.
you.
Welcome. Berries, just add this provider block with provider name AWS and save your file, open your terminal and run Terraform init command and see if the plugin is downloaded or not. You can wait for this. Once done, open your file explorer and navigate to .terraform folder and see you have got the same directory structure created or not.
Quick questions. My previous
Yeah.
lessons, is it not a good practice to have all the providers in the, I mean, maybe you use 3 different cloud and create a provider.tf file and be done with it. So every time you create a main.tf, you don't have to declare it anymore.
Yep, we can do that, Sean, definitely. And you don't even need to do this in every directory. You can have one common directory where you download the plugins and you can use that directory in any other directory to point out when you want to use plugin. So as we move ahead, I will show you how to do that. Okay. Right now we are only going with one provider, but if you want, then multiple provider definitions can be provided in the same block.
Okay, thank you.
Yep.
Does this step install the plugins that you mentioned?
In the desktop,
Hmm.
the folder that you have created, in
Okay.
that folder, there is a .terraform folder
Yes.
where you will get the folder. So keep opening the folders, providers, registry, HashiCorp, AWS, the version, the architecture, and then you will see the file.
Yeah. So my question is this the plugin that you are talking about?
Yes, exactly.
So for each providers, we have to do the same step.
Yep, if you are using separate providers, the plugins will be needed. And if you're not, if you're using only one provider, then it's only a one-time step. Done for once, not needed anytime longer. After this, you will write the configuration files and start defining your resource creations.
We establish the connection to the AWS portal.
No, not yet. We will do it next step. We will have to define the connection, how it will be done. The authentication mechanisms are different for every providers. We will see how it is done for AWS.
Okay. So in your demo, you are only going to show the AWS, right?
Yeah, we will be using AWS only. While equivalent to this, if you want to see and practice, then we do have the recorded available on the K21 portal. You can check that and you will get the same way how to do it for Azure, and you can practice it post session.
Got it.
Yep.
Thank you.
Okay.
Yeah.
Please, can you repeat the step before downloading the Terraform Architecture?
Downloading Terraform HashiCorp plugin or Terraform.
The plugin.
So did you write this configuration in the file?
Get that. I didn't get that.
So first create this file, first file.tf. You can click on this icon to create a new file and then add this configuration to your file. Write it down. Provider name.
Okay.
It's going to create that new file, and that is where we are lost. So where's your screen?
You have to create it inside K21TF folder that you made on desktop.
Okay.
So to create that, you just in front of your folder name, you have this icon, the first icon to create a new file. You can click on this.
Is it like an home screen or something?
The view is different.
If view is different, you can go to file and click select new file.
File, new file, new file.
Then it will ask you for file name. So you can give first file.tf.
It will only pick it if it's there. Okay, right provider. Space.
Which one is it?
This one.
Oh, that's one.
Voice, yeah, that's right.
No.
You would have to look back at
Only.
it.
Yeah.
Okay, let me go again. So,
All right. Yeah. I think so.
Yeah?
Yeah, let me get it.
okay. Did you see the file? Okay, that's it.
Mm-hmm.
And then it said save.
Save.
Mm, Not source control section. I don't think you should be seeing all this.
This one, this right?
Yeah, because this is not showing that. Okay, save. Control V, right? Sorry, Control S. Let's go to file save. Do it again. Yeah, pause it. Do file save just to make sure it's saved. Is that saved? Yeah, saved. Then what's the next thing? Akil, after file save.
After file save, now open your terminal. You can open your terminal from the top menu bar, terminal, new terminal.
Okay. That's three icon terminal and the new terminal. Yeah.
Yeah.
And now on your terminal, you can run the command Terraform init.
Terraform init.
Yeah.
Space, yeah. Init.
Mm.
Okay, then enter.
And enter, and then you wait. See if it is downloading the plugin or not.
The directory has no Terraform configuration file. You may begin working with Terraform immediately by creating Terraform file.
So match the name. Your terminal is not in your current directory. That means something is not matching. You see, my folder name K21TF is what I see in my terminal. That is why it is matching the same configuration directory. For you, if it is giving a message that Terraform has no configuration files, that means the working directory on terminal is not same as working directory on VS Code.
So how do we correct that?
Yeah, so to correct that, what you can do is go to your file explorer and check that where is that file. Is it inside desktop K21TF or not? If not, then drag and drop it here in K21TF. Is your terminal open under K21TF? Do you see the terminal with the folder name that you have created?
I don't think we saw K21TF. It's not. Did you see K21TF? Yes. No, there's no K21TF here. We might have to just look at the video again. Oh, no worries. We'll have to look at the video again.
We'll watch the recording all over again. Don't worry. That's
Yeah.
no.
Thank you.
Okay, so we have got this provider downloaded. Let's move. Now let me share back my presentation. Okay, so this was good about providers. Just give me a second. Okay, so now when we talk about providers, the next thing is about the provider version. How you define the provider version. Like for example, for compatibility issue, you don't want the provider version to change every time you run Terraform init command. So you need to restrict your configuration to a certain version, because if you don't, it will always by default go to the latest one. Like here it is 5.6.1. And how you see if you go back to VS Code, provider AWS, you see this is the version 5.6, that is the latest one. But now if you want to restrict to any specific one, let's say you want to go to some older one like 5.55. Okay, so how do you specify that version? So in order to do that, you have to again go to the use provider, and this is where this Terraform blocks come into picture. Okay, so this block says you can edit anywhere in the order at the top or bottom. So this block says Terraform, we need a provider, required provider called AWS. Source is from HashiCorp AWS, and version whatever you want. So right now it is going for the latest one. Let's change it. Let's say this is 5.55.0. Okay, and now if I save, I'm going to delete, or let's not delete. You see, earlier the version was 5.56. Now I am changing the version. Either I am downgrading or upgrading, doesn't matter. If I am changing the version, and now if I again just try to run Terraform init command, Terraform will not allow me to do that. Terraform will say, reusing the previous version of AWS, from which file? From this lock file which is created. So in this folder, it's not just Terraform. There was a log file which was also created, terraform.log.hcl. So this is the file which actually contains information about the hashes of the version of your provider. So it is kind of putting a constraint that this is the version that has to be used with this configuration, cannot change that. So due to this file, since it contains 5.56, if I'm trying to change it to any other version rather than 5.55, it will not allow me to do that. Why? Because it is reusing from the log file. So this file is like providing a lock to your provider safety version. Now, if you want to override that, you should not do any manual changes to this file, because this file is maintained automatically by Terraform init command. So there should be no manual changes. Okay. Only Terraform init, and then you have to use option called -upgrade. -upgrade. When you hit enter, now it will allow you to change the version. You see, it says that finding the new version matching 5.5 that you have given in this file, and now installing 5.5. So the previous version, which was 5.56, will now be overwritten. And this file now, once it is done, you see the log file now contains information of 5.55. And in my directory plugin, inside .terraform providers registry HashiCorp AWS, you see now we have got both the versions available, 5.55 and 5.56. So now 5.5 is being used, although it also maintains the previous version. So whenever you need version of your provider, you have to add this Terraform block. And you can add this Terraform block always from Terraform registry for any provider. It is always same. The syntax is always same. Only the provider name will change. HashiCorp / AWS, Azure, GCP, Oracle, and so on. And the version, of course, because every provider has got their own versions. Okay. So all of you go ahead and try changing the version of your provider. and let me know if it is done and if you have any doubt. If you are facing any issues, you can share your screen. I might help you and we can come to the same page. Please don't keep yourself behind. If you have any doubt, just ask me that, hey, Akhil, I want to share the screen. I'll give you permissions and then we can troubleshoot the error together.
Uh,
Yes.
I just tried it and pasted the code, but it's not showing me any error. I
Now
tried with Terraform.
save your file and then run Terraform init command. Change the version.
Oh,
You might have not changed the version. Change it to 5.55.
yeah. I just did it because I went to the downloads, the site, and from there only I just downloaded the code. I went to that registry.terraform.io And from
Yeah,
there, I used
save your file and then try.
say, I think so. I just need to save it then.
Yeah.
So saving this file might be a case. So yeah, that can be one. I tried with Terraform initialize and just want to see the error is coming, but yeah, now there, yeah, it was. Yeah.
So saving file is a very important task. Everybody has to keep that in mind. Your voice is breaking. I can't hear you if you're saying something somebody was just saying. Okay, everybody has done. So let's move ahead. So that's good. So we have got this provider version done. Now we can also provide the operators with provider version in order to, constrain the provider version. Like, for example, we don't want them to go in a more than that particular series, or we want to be greater than, less than to the version. Okay, so we can use these operators to put a constraint on the provider versions. And this can help us to limit that which version we want of our provider. So let's say, let me show you this. For example, if I'm saying that I want the Terraform provider version, like today it is 5.55, right? So I'm okay for going it beyond 5.55 also. Okay, so I can say version is equals to greater than equals to 5.55. So whatever version at that point of time comes latest, this will match that latest version and will have my plugin. This is equivalent to the latest version. But the advantage of mentioning this is my documentation, keeping a track that today on 29th June, when I made my infrastructure, my provider version was 5.55. After 6 months, if I again run init command, maybe this 5.55 might go to 6 point something or 7 point something. It will get the latest plugin. But if somebody asks me that, hey, Akhil, what was the version of your provider when you made your infrastructure? I can simply understand that this was the version of my provider. So this operator will help me to do that. Like, for example, see, if I save it and if I run Terraform init upgrade command, you will see it will go to 5.56 automatically, because that is the latest one available today. You see, 5.56. So tomorrow, if HashiCorp releases a new version, and if somebody runs upgrade on my configuration, again, it will match that latest one available that time. But keeping a track that when this infrastructure was created, this configuration was written, the version of the provider was this. Similarly, I can also keep it to less than equals to. So if I give it less than equals to, then it will not go beyond 5.55. It will always keep this as the maximum. This is the maximum. So for example, if I say less than 5.5 and then upgrade, you will see it will again roll back to 5.55. You see 5.55. It is not going to 5.6 now, because less than 5.55 or equals to 5.55, but not more than that. So this is how we can keep this. Same way, interesting one is, if you want to keep in the range, like you are okay with 5-point series, but you don't want it to go to 6-point series, because you know that there might be major updates when it goes to 5 point to 6 point, right? Because after a point, this is my patch and this is my small minor updates. So these might not bother me, but I don't want them to go to 6 point for my compatibility issue, right? So I can say here that anything in the range, so I'll use tilde operator, anything in the range, okay, and then I can say 5.0, anything greater than in the range of 5.0. So if I save this and if I do Terraform upgrade, anything greater than 5.0 right now, what is the available one? 5.56. So it will go up to 5.99. But the moment it becomes 6.0, it won't take that update. Why? Because I have kept 5-point series. Because I know that there might be major updates if the first bit updates, right? So I'll keep it to 5.0. In this way, you can put a range constant. Okay. You can also use between, so you are saying, Akhil, I'm okay between 5.2 to 5.4, but not above that. So you can say greater than equals to, let's say 5.20, comma, less than equals to 5.40. Should be less than, sorry. Less than equals to 5.40. So now in this case, if I run Terraform upgrade, this will always be between this only. So right now it is 5.56, right? So I can say 5.56 to 5.99, but not above that. So you see it's taking only 5.50 maximum. Now you might be thinking, Akhil, what will these providers, operators do? So I told you these are just for supplying the information of my provider, that which version I'm using. Good for infrastructure, so that if there is any stability or compatibility issue, it can be easily troubleshooted by checking that which version of the provider was this infrastructure created on. Okay, so this is the provider version. Now next comes the authentication. So authentication for Azure can be done using Azure CLI, and there are other ways. I will not talk about them here. We will do the authentication for AWS. But before that, let's run through the presentation. We have fetched the providers. We have got init command, and we saw how the plugin directory was created. .terraform plugins, all these directory are created. So Terraform initialize will look for provider, retrieve the plugins, check the version, and then store them into .terraform subdirectory. So we have seen this complete workflow. Now, next thing is the multiple providers. Multiple provider means you want to have different providers, or for same provider, different configuration. It can be anything. Like you are saying, Akhil, I want to configure AWS, one for East US, one for West US. I want to use same. So whenever you want to use multiple providers, use the concept of alias. You give alias name, alias, and then in which region you want. And then whenever this provider needs to be used, then you provide the alias reference. How we will see this when I will start creating resources. Today, I just wanted to show you that how these alias can be referenced by using alias argument in your provider block. The meaning of this is I can have two different configurations. maintained by my provider. Okay. So let's say I will be in a more better place to show you. Okay, let me show you this here itself, because we are using anyways provider block. So one provider here I have, so I can save my region for this is going to be, let's say, US East 1. Then if I want another provider with the same name, because if you don't use alias, then you cannot have provider with the same name. You see here, if you're saying region is, for example, US West 1. So if you try to do Terraform init in this case, Terraform will throw you an error saying that duplicate provider, because both of them are same name, so not allowed. You can have different names, that's okay, but same name not allowed. So in this case, I will have to use alias argument. So I will say, okay, this will be known with an alias. Alias as AWS for West US. You can give any alias of your choice, a proper naming convention which helps you to identify. So now in this case, it will not give me any error because now it has identified that particular provider with the alias. You see, this time no error. It was successfully done. So same provider with different configurations. This is okay. If you want different provider, it is simple. Just go and add provider block and say, for example, OCI. That's it, done. You want to use Google, just say Google. See, I'll write Google, save, and I will run Terraform init command. It will download the plugin for Google for me. I've not given any version, so it will go for the latest one. You can see matching the latest one from the Google. And that's the latest provider that we have got from the Google as well. Okay.
So is there any specific command in the documentations where we use the alias?
It's not just in documentation, it's in the case. I'll show you live tomorrow when I will create resources after authentication, that maybe you have authenticated your credentials, but you want to create IC2 instance, one in East US and one in West US. So instead of writing two separate configuration file with one single configuration, you can do that by just adding a alias. Does that make sense?
Yeah.
So this we will see when we will do it tomorrow, because today we are not doing the authentication yet till now. So providers, okay, we understood. We have installed Terraform CLI and editors and all, so this is done. Now let's talk about the workflow. So these are the commands that we are going to use when we are using Terraform. First thing that we have done is init. Init command actually downloads the plugins for you. After downloading the plugin, you write your configuration files, and The configuration files are written in HCL language. Once it is done, you do a plan, Terraform plan. So Terraform plan command is actually like a dry run in Ansible. It actually do a comparison of your infrastructure, that what is your current infrastructure and what is your desired infrastructure that you have written in file. It will do a comparison. It will not do the changes. It will just do a comparison. If mismatch, it does not match what it needs, then in that case, it will propose you the plans that, hey, these changes needs to be done. It will not do the changes. It will just show you the plans. That is what Terraform plan does. So it is always a safer option to do Terraform plan before doing the actual changes, so that you can see that what all changes will be done. Once you are happy with the plan, then you go for Terraform apply. So Terraform apply is the command which actually does the execution, which actually creates your infrastructure or modifies the infrastructure. Terraform apply. Once you have done apply, you will see your infrastructure resources running. As long as you use them, it's fine. If you don't use them, you use the command Terraform destroy. So Terraform destroy will delete the infrastructure. So this is the workflow that we use in Terraform. Init is only a one time unless you change the provider version or any other configuration. You don't have to run init command. Then plan, apply, destroy, all these commands runs on directory level. That means if in a directory I have 5 files, 10 files, all the files will be loaded in the memory and my plan will be created. My apply resource will be created or modified. My destroy resource will be destroyed or modified. Sounds good, everyone? Any question you can ask me here, because now next almost 20 hours of session that we have, 20 to 24, whatever time it is, you will see these commands running a lot. Terraform plan, Terraform apply, Terraform destroy, Terraform plan, apply, destroy. We will keep on moving along these 3 commands only. Init initially in the beginning of the day, and then throughout the day, plan, apply, and destroy. So you should know that what each of these commands do. Okay. I'll take a pause for a minute. If you have any questions, you can ask me. Otherwise, just go through the PPT, read it, and let me know if you have any question. Barry, of course, we don't use the plan in a pipeline. When you run Terraform in a pipeline, we don't use this, but you have to be careful that the direct execution should not be done. There should be a confirmation taken. Otherwise, every change will directly infect your infrastructure. So you should be careful in that. Okay, so I'll take that silence as no question. Moving ahead. So this is the summary of what we have just discussed. Developer writes the configuration and then execute all these commands: init, plan, apply, destroy, and keep on changing the infrastructure accordingly. And the information of all the updates is written in terraform.tf state file. Okay, tf state file. This is the file that contains infrastructure information that you will see. As of now, we don't have this file because we have not created any infrastructure. This file is created only when you start creating the infrastructure, not before that. So let's get started. So we have installed Terraform. We have got the provider to decided. So we have decided AWS for this task and labs. And we have initialized the providers. We have got the workflow now that we need a dry run, apply to create a resource, update a resource, or delete a resource. Okay.
So the
Yeah.
so when it tf.state file will happen only when we try to apply it, right? We try to save that in the
State file gets created only when you do the first apply. After that, the state file keeps on updating for every update, delete, whatever you do. But before the first apply, you won't see that file.
Okay,
So
applies
right
having
now,
two states.
yes. So right now
Create
we have not done any apply. So that's why we don't have any state file. Tomorrow when we will do apply, we will see state file in our directory, and then that file will keep on updating on an every command that we run. So what do you need to get started? We need a cloud account. So tomorrow, everyone make sure that you have an active AWS account with a subscription, either free trial or pay as you go, whatever you want, you can choose. We want to make sure that everybody has an account. If you need any help in creating an AWS account, free trial account, we do have a guided video for that available on K21 dashboard. Please go ahead and search for that. You will get a video that will help you how you can create your trial account on AWS, because tomorrow we will need that account in order to start our resource creation. Okay. Then we will set up our authentication. Executables are all set. VS Code is all set. So everything is in place. It's just that we need the account tomorrow ready. So summary of this module, we talked about installation, providers, the architecture, the execution, workflow. Okay, so this completes our module number 2. Now a small task for all of you. Just to practice what we have done, I'll put it on the Etherpad. First, I will put this configuration on the Etherpad. So I'm going to copy this. Providers. Main.tf file is what I'm taking. This is the file name as first file.tf, right? So I'll give it name as first file.tf. Okay, so now the tasks. That's your task. Go ahead, everyone. Once you have done, you can share the screenshot in the chat, or you can also let me know if you want. You can share your screen and show me the output.
One question. So what is the best practice that we will be able to give for the provider? That's is it the exact provider with the
Terraform
version?
block. Yes, you will always see the best practice provider with the Terraform block.
Terraform block, in a sense, it's the exact version we will
The
use.
exact version, yes. This Terraform block. Okay, I can see one output shared in the chat. I mean, one configuration shared in the chat. Thank you, Joffy. That works. Perfect. Good. I hope you use Terraform init-upgrade command. Yep, I can see. Perfect. You have shared that command also. Thank you. Others also, if you need reference, you can see. Joffrey, can you please put this on the Etherpad so that it can work as a reference for others also? Just add here as a solution on Etherpad. Everybody can edit this file. So if you feel anything important I have not added, just add it here. Thank you. So that will be all from my end for today, team. Meanwhile, you are doing it. If you have any questions, you can ask me. I'm available here for 5 more minutes. If you have any questions, you can ask me. Otherwise, we will start our next topic tomorrow. You are most welcome to drop off if you have no questions and if you're done with the task. Thank you for joining today. Tomorrow, make sure that you have your AWS accounts ready. And if you missed something setting up today, you missed some step in between, please do watch the recording and get yourself on the path so that we all are on the same page when we start tomorrow. Sounds good, everyone? So
Sorry, Akil, am I missing something? How do we get the slides?
the slides are available on
today?
the slides are available on the K21 dash portal. Please go and check. Same
K21
slide decks are
dashboard.
available. Yeah.
Okay, thank you.
Yep, you're welcome.